Hello, today I'm going to go over coefficient of variation practice. So this has to do with the distribution of our data. Now we already talked about standard deviation. So standard deviation is moving out from the mean and where your data lies in comparison. Now we're taking another look at where the data is when we're considering the mean. And what this does is it's going to tell us how varied our data is. So this number here, the coefficient of variation, if it's a small number, that means all of our data is really packed tightly close together to the mean. It's very close to the mean. If the coefficient of variation is larger number, then that data is more spread out. It's further away from the mean. So depending on what kind of data sets, this is good for comparing two different data sets where you have different numbers, but you want to know which one might be more varied than another one. So we're going to just start right off with it. Down here, it gives an example, gene expression, analyzing the coefficient of variation, that's CV, of gene expression levels in two cell types to determine which cell type exhibits greater variability in gene activity. So we've got muscle cells and skin cells. Well, muscle cells have this higher number. So it's not how much they're expressing these genes, but what's the variability of it? Like how different is it from the mean? So that's what we're going to look at. Let's start by using this formula right here. Standard deviation divided by the mean times 100 will give us our coefficient of variation. So 478 divided by the mean, 1855 times 100. And when I do that, divided by 1855 equals times 100. Now we're going to round this to one decimal. So 25, this 25.76 will get rounded up to 25.8. Now we're going to do the next one the exact same way. Standard deviation, which is 7, divided by the mean, which is 565. Multiply that by 100. 7 divided by 565 equals times 100 equals 1. Now it's 1.23. So to round it to one decimal point, we're just going to keep it at 1.2. And since we're looking at the variability of gene activity, how varied the activity is, these numbers tell us which one has a higher variability. So just because these numbers are bigger doesn't mean it has a higher variability. In this particular case, it does. 25 is larger, so the variation is higher. Where skin cells, lower number means that, again, the data is packed tightly together, not as much variability. And then we want to make sure that we circle the data set with a smaller coefficient. So smaller number, I'm going to circle skin cells, okay? Let's do one more, enzyme activity. So we do it the same way. Standard deviation, 5 divided by the mean, 16 times 100 equals 5 divided by 16 equals times 100. 31.25, so we're going to round that to 31.3. Next one is 2 divided by 8, right? 2 divided by 8 times 100. Well, that's 1/4, so 2 divided by 8 equals 0.25 times 100 equals 25. Now these numbers are closer, But there's more variation in this 40 degrees set and less variation in this 20 degree set. So remember, we're going to circle the smaller coefficient of variation. In this case, it's this one. Now you're going to do the same thing for the rest of these examples and do it the same way that we did these first two. Let me know if you have any questions.